Tuberculosis is affecting millions of people, mainly in the developing world, and kills approximately 10 people in every 3 minutes. Drug-sensitive tuberculosis is treated for 6 months with combination of different antibiotics, and drug-resistant tuberculosis even longer. Active tuberculosis is caused by bacilli called mycobacterium tuberculosis, and what is making this bacteria hard to treat is their unique, thick, hydrophobic cell wall composed of polymers of sugars and lipids. So to fight against this pathogen, this is the wall we need to break. But how can we do that? We can do that by identifying the key enzymes, or let's say the key builders who are responsible for building this wall, and by finding the right molecules which will stop their function. That's why we've studied mycobacterial VEC-A protein as a potential novel drug target for anti-tuberculosis drug development. We were testing a new antibiotic from our collaborator, which was active on replicating mycobacteria, and found out that it is inhibiting activity of this protein. This caused that the major polysaccharide couldn't be formed, making the wall incomplete and fragile. Unfortunately, this molecule was toxic in mice, so it couldn't be used for treatment of tuberculosis. However, it has a dual mechanism of action and inhibits also another protein which has similar function but utilizes a different sugar substrate. So my goal was to develop a method for parallel monitoring of activities of these two proteins simply by using two different sugar substrates. The products of these reactions can be extracted and analyzed by TLC, where they migrate into different positions. When the protein is inhibited by the tested molecules, the product will not appear. By this method, we can also identify the selectivity and efficacy of the tested compounds against these two proteins. And to scale up to accelerate the procedure of drug discovery, we are now going to scale up these assays in 96-well filter plates using hydrophobic beads which trap the product of two reactions. And these assays are suitable for medium or high throughput screening of inhibitors. By targeting these two proteins, the essential bricks in the two important layers of the cell wall will be missing, and by this strategy, we can break the wall of mycobacterium tuberculosis.